welcome. Let's look at derivatives. So if the derivative of a function is its slope, then for a constant function, the derivative must be 0. So here I have graphed the line y equals 3. And if we look at that line has a slope of 0. Right? And since the derivative is just the slope of the function at various points, and the slope of y equals 3 is 0 everywhere, the derivative of y equals 3, or y equals any constant, must be 0. So the derivative of a constant is 0. The slope of a constant function, y equals plus or negative c, where c is just some number, some constant, is 0. Therefore, the derivative is 0, because remember, the derivative is just the slope. For a given value of x, actually let me say for a given function at a given value of x. However, here, no matter what the value of x, the derivative of a constant is always going to be 0. Let's look at some other derivatives. And so I've already actually used the definition of the derivative to find half of these derivatives. The other half I'm going to find with you. My hand gets kind of tired up in the air as I'm writing these. So sometimes it's nice to have some of them done, right? And then I'm going to do the others with you. And we're going to see if we see a pattern. So this part is review, but we want to see if we see a pattern after we look at the derivatives of several polynomial functions. So here's my first function. It's f of x equals 2x squared. Right? So to find the derivative, and actually I'm going to have a handy dandy little arrow to do my pointing for me. There's my handy dandy arrow. Let's see if I can, whoops, no, I don't want any more arrows, just one. What I wanted to do is take my arrow and let's make it a color. Oh, a nice bright color. Actually, that's pretty bright. And I'm going to rotate that a little bit. There, now you'll know where I'm pointing. And I'll just drag the arrow with me from screen to screen. All right, so here, maybe my arrow should be a little smaller. There. All right, so here we are on the first line. All right, so we want to find the derivative of 2x squared. We know that the derivative, f prime of x, is the limit as h approaches 0. Right, so we're adding a teeny bit, and that teeny bit's going to 0. So it would be the limit as h approaches 0 of 2 times x plus h squared minus 2x squared, all divided by h. And then, of course, squared out x plus h. Right? And that's pretty easy to do, right? That's x squared plus 2xh plus h squared. Right? And then in the next line, I'm right here. In the next line, I just distributed the 2. So we have the limit, so f prime of x equals the limit of h as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 2x squared, all divided by h. And now I look and I say, hey, I've got a 2x squared and a negative 2x squared. I can combine those, right? So that no more 2x squareds. Right, so now I have f prime of x equals the limit as h approaches 0. We have 4xh plus 2h squared divided by h, and I look and I see, hey, both those terms have an h. And you might have wondered, hopefully you didn't, but you figured this out, but notice I don't fill in the value h equals 0 until I've canceled out that denominator, right? Because this is an indeterminate limit, right? And I've got to simplify it until it's not an indeterminate limit. Right, so right now it's not going to be an indeterminate limit because I'm going to factor out the h. I also decided to factor out the 2. You'll see it really doesn't make any difference, and after a while I got tired of factoring out the constant here. But I did on this one. So we have f prime of x equals the limit as h approaches 0. I can cancel out those two h's, the h in the numerator and the h in the denominator. That leaves me with f prime of x equals 4x. And then we're going to, now we can, once we plug in Once we plug in the 0 for h, we're going to drop the limit because now it's no longer a limit, we're evaluating. So it's a limit, but we're evaluating. So we don't need to say limit anymore once we get to the evaluating stage. So we have f prime of x equals 4x plus 2 times 0, right? Because h is 0, h is approaching 0. And so that term is just 0, we don't need that. And so my derivative, f prime of x equals 4x. Now you're going to look for a pattern between the function and its derivative in these particular examples. I'm going to do the second example after I get rid of this arrow. I'm going to try to get rid of this arrow. There we go. Okay. Go away. All right, so I'm going to move this one. And so I'm going to do the second example at the bottom of the page here. Now it's pretty similar. All right, so we have g prime of x equals the limit as h approaches 0 of 4 times x plus h squared minus 4x squared, all divided by h. I think I can get one more line in so I don't run out of space. So that is g prime of x equals the limit, there we go, as h approaches 0 of 4 times x squared plus 2xh plus h squared minus 4x squared, all divided by h. So now let's distribute that 4. So we have g prime of x equals the limit as h approaches 0 of 4x squared plus 8xh plus 4h squared minus 4x squared, all divided by h. Now those 4x squareds are going to cancel. I think I can fit it over here. So we have g prime of x equals the limit as h approaches 0, and we have 8xh plus 4h squared. Wait, did I forget somebody? I'm feeling like I forgot somebody. Okay, that's fine. 4x squared, 8x, no, I got everybody. Okay. I don't know why, I just felt like I was missing somebody. So g prime of x equals the limit as h approaches 0. Now I can factor out the h, so I have 8x plus 4h. I'm not going to bother to factor out the 4 because it's not like it's going to cancel. That's an x. All right, but the h's will cancel. So that's going to give us g prime of x equals 8x. I can plug in the 0 for the h because now we're evaluating our limit. And of course, that's just 0, and I don't need that. So g prime of x equals 8x. Right? So just to point out something, all right, so on the first one, the function was 2x squared, the derivative was 4x. In the second example, the function was 4x squared, the derivative was 8x. I'm going to take my arrow with me. All right, the next one I did already. Kind of similar. All right, this one, h of x is 6x squared. So we take the limit as h approaches 0 of 6 times x plus h squared minus 6x squared divided by h. All right, so we square x plus h. So we have h prime of x equals the limit of 6 times x squared plus 2xh plus h squared minus 6x squared, all divided by h. Then we can just distribute that 6. So that gives us h prime of x equals the limit as h approaches 0 of 6x squared plus 12xh plus 6h squared minus 6x squared. Of course, the 6x squareds are going to cancel. And we're left with h prime of x equals the limit as h approaches 0 of 12xh plus 6h squared, all divided by h. We can factor out the h. I factored out the 6 too, but you see, I'm just going to have to distribute, so it really doesn't make a difference. So h prime of x equals the limit as h approaches 0 of 6h. The h's we can cancel because we have an h in the numerator and an h in the denominator, times 2x plus h. I'll just distribute that 6 back again. I don't know why I factored them out. I was being a little too efficient. So h prime of x equals 12x plus, I can substitute 0 in for the h. So that's going to give me 12x plus 6 times 0. I don't need that 6 times 0. So the derivative, h prime of x, is 12x. So the function, h of x, is 6x squared. Its derivative was 12x. I'm going to do the next one with you. This one is 2x cubed. Right? And so this is I prime of x equals the limit, there we go, as h approaches 0 of 2 times x plus h cubed minus 2x cubed, all divided by h. I think I'll have enough space here if I don't write too big. I prime of x equals the limit as h approaches 0. All right, so we're going to cube x plus h. And I am just doing these in my head. If you don't know how to do these in your head, I'll show you at the end of this tape. Sorry. So we have 2 times, I forgot, I was cubing. Don't write it, cube it. X cubed plus 3x squared h plus 3xh squared, squeeze this in, oh, I don't know, and then plus h cubed. I've got to squeeze in a minus 2x cubed. I think if I move this over just a little bit. Uh, 2x cubed. My shadow keeps blocking me. I feel like I'm a boxer. You know, I gotta go this way, go that way. Bob and weave. That's what I was trying to say. Gotta bob and weave so I can see beyond my shadow. All right, so I prime of x equals the limit as h approaches 0. Let's just distribute the 2. So we have 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 2x cubed, all divided by h. The 2x cubes will cancel, so that gives us I prime of x, oops, missing my prime there, equals the limit as h approaches 0. And then we've got 6x squared h plus 6xh squared plus 2h cubed. And we can just, let's just factor, all divided by h. Let's just factor out the h, since we're not going to cancel out the 2 anyway. So we have the I prime of x is the limit as h approaches 0. We'll factor out the h because we need to cancel that out. So we'll have 6x squared plus 6xh plus 2h cubed, plus 2h squared all divided by h. We'll cancel out the h. So now we have I prime of x equals, we're left with 6x squared plus 6x. I'm going to substitute for h right at the same time so I don't have to write the limit one more time. So we have 6x squared plus 6x times 0 plus 2 times 0 squared. All right, so that means that the derivative, I prime of x, is equal to 6x squared. All right, so the function was 2x cubed. Its derivative, I prime of x, is 6x squared. You see any relationship? Let's do another one, and I think the next one is done. So I'll just go over it. It's nice I get to put my hands down for a moment. All right, so we have 4x cubed. All right, so very similar to the last problem except for a coefficient of 4. So we have j prime of x equals the limit as h approaches 0. 4 times x plus h cubed minus 4x cubed, all divided by h. So we cube that, so that would be j prime of x equals the limit as h approaches 0 4 times x cubed plus 3x squared h plus 3xh squared plus h cubed. Hopefully you see the pattern in the exponents, and I'll show you the pattern in the coefficients momentarily. Minus 4x cubed, all divided by h. All right, so then I just distributed the 4. So now we have j prime of x is equal to the limit as h approaches 0 of 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed minus 4x cubed. We can cancel out those 4x cubed. That's all I did to go from one step to the next. All right, and then we're going to factor out. This time I did factor out the 4h. I really could have just factored out the h. So we have j prime of x equals the limit as h approaches 0 of 4h times 3x squared plus 3h plus h squared. Right? And so now I canceled out the h's and I distributed the 4 back. So j prime of x is equal to the limit as h approaches 0 of 12x squared plus 12h plus 4h squared. All right, so now I can drop limit once I plug in. So I have j prime of x equals 12x squared plus 12 times 0 plus 4 times 0 squared. Well, that's just j prime of x equals 12x squared. So notice the original function j of x is 4x cubed. Its derivative is 12x squared. All right, I'm going to do this one with you. X to the 4th. K of x equals x to the 4th. So we have k prime of x is the limit as h goes to 0 of x plus h to the 4th minus x to the 4th, all divided by h. I think I have enough space on it if I just, actually, you know what, I have this whole page. I don't really have to cram it in. So k prime of x equals the limit as h approaches 0. That would be x to the 4th plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th minus x to the 4th. All divided by h. All right, so all I did was I just raised x plus h to the 4th power. All right, those would be our terms there, and with the correct coefficients. Notice how the exponents, one's going up and the other one's going down. All right, so that's really easy to figure out that part, and I'll show you how to figure out the coefficients if you don't know. All right, and let us cancel out those x to the 4s. So we have k prime of x equals the limit as h approaches 0. We're left with 4x cubed times h plus 6x squared h squared plus 4x. Wait, make sure I wrote everyone down right. I didn't miss anybody. 6x squared h squared, yeah. 4x h cubed plus h to the 4th. Again, I have to keep having to bob and weave so I can see past my shadow. K prime of x equals the limit as h approaches 0. Let's factor out the h. Let's leave, actually that's all we have is an h that we could factor out. So we have 4x cubed plus 6x squared h plus 4xh squared plus h cubed. All divided by h. We can cancel those out. So now we have the limit. We have k prime of x is the limit as h approaches 0. We're left with 4x cubed plus 6x squared h plus 4xh squared plus h cubed. And then k prime of x equals the limit as h approaches, oops, excuse me, I'm done with h, the limit. We're plugging in, we're plugging in. There's nothing more to do. Get into a rhythm here. K prime of x equals 4x cubed plus 6x squared times 0 plus 4x times 0 squared plus 0 cubed. All right, so that's just going to be 4x cubed. So the original function k of x was x to the fourth. Its derivative, k prime of x, is 4x cubed. Right? Maybe you see a pattern here. I think I have two more. This one's all done out. All right, so I just go over this one. Almost the same thing with a 2. All right, so L of x equals 2x to the fourth. L prime of x equals, by the way, none of these are in your notes. I just want you to see I just want you to think about the pattern. Is the limit as h approaches 0 of, and then to find our derivative using the definition of the derivative, right? We're going to raise x plus h to the fourth power minus 2x to the fourth divided by h. Right, so x plus h to the fourth power is so that would be the limit as h approaches 0 of 2 times x to the fourth plus 4x cubed h plus 6x squared plus 4x h cubed plus h to the fourth minus 2x to the fourth. All divided by h. I distributed the 2. Oh, I forgot my little arrow. Here he is, and he even matches kind of nicely. All right, so I just don't want to move. All right, and then we can cancel out those 2x to the 4s, right? We've got a positive and a negative. So that's going to leave us L prime of x equals the limit as h approaches 0. 8x cubed times h plus 12x squared h plus 8x h cubed plus 2h to the fourth, right? So all I've done is just cancel out the positive and negative 2x to the fourth. We can factor out the h, which is what I did on the next step. Right? And so then we have L prime of x equals the limit as h approaches 0. Everybody's down 1h. 8x cubed plus 12x squared h plus 8x h squared plus 2h cubed. We can, if we want to drop limit, we can either, at this point there's nothing more to do except for to drop the term limit and plug in the 0 for h. So L prime of x equals 8x cubed plus 12x squared times 0 plus 8x times 0 squared plus 2 times 0 cubed. Well, that leaves us a derivative of 8x cubed. So the L of x was 2x to the fourth. L prime of x was 8x cubed. All right, I'm going to do x to the fifth with you. All right, so that's going to be the, oops, I forgot to write m prime of x. M prime of x equals the limit as h approaches 0, x plus h to the fifth minus x to the fifth, all divided by h. Yeah, I think, you know what, I'm not going to cram it. I've got a whole page here. M prime of x equals the limit as h approaches 0 of x to the fifth plus 5x to the fourth times h plus 10x cubed h squared plus 10x squared h cubed plus 5x times h to the fourth and then h to the fifth. Glad I didn't cram it, it wouldn't have fit. All divided by h. Oh, don't forget minus x to the fifth. Here we go. Now we can cancel out the x to the fifths. So m prime of x equals the limit as h approaches 0 of 5x to the fourth h plus 10x cubed times h squared plus 10x squared h cubed plus 5x h to the fourth plus h to the fifth, all divided by h. Let's factor out the h. So m prime of x equals the limit as h approaches 0. Factored out the h. 5x to the fourth plus 10x cubed h plus 10x squared h squared plus 5x h cubed plus h to the fourth, all divided by h. We cancel out the h, and so that gives us m prime of x equals the limit as h approaches 0 of 5x to the fourth plus 10x cubed h plus 10x squared h squared plus 5xh cubed plus h to the fourth. By the way, if I ever talk too fast, you can slow down the sound on the Nearpod. All right, so we're going to plug in 0 now. So m prime of x equals 5x to the fourth plus 10x cubed times 0 plus 10x squared times any day now. There we go. All right, well, everything is going to drop out except for the 5x to the fourth. So the derivative is 5x to the fourth. So the original function was x to the fifth. Its derivative is 5x to the fourth. I'm going to go over one more. It's already done. And that is 3x cubed. All right, so n of x equals 3x cubed, and prime of x is the limit as h approaches 0 of 3 times x plus h cubed minus 3x cubed divided by h. Right, we'll expand the x plus h, so that would be x plus h cubed, so that would be limit as h approaches 0 of 3x cubed plus 3x squared h plus 3x h squared plus h cubed minus 3x cubed. Distributed the 3 in the next line. Oh, lost my little arrow. So distributed the 3 in the next line. All right, we canceled out the 3x cubes because there's a positive and a negative. That takes us to this step. We can factor out the h, cancel that out. I wisely did not factor out the 3 because it wouldn't have made any difference anyway. I would just be distributing it back. Right? And so that gives us h prime of x is the limit as h approaches 0 of 9x squared plus 9xh plus 3h squared. I'll now drop the limit and plug in 0 for h. And everything is going to cancel out except for the following. N prime of x equals 9x squared. So the function n of x was 3x cubed and prime of x was 9x squared. So hopefully you saw a pattern. Right, I'm going to have you make a prediction on that pattern, and then we'll see what that pattern is in the next Nearpod. By the way, even if you have not done definition of derivative homework, remember that's using the definition of the derivative, right? Not any shortcuts. So mathematicians noticed a pattern too. In the future, we can take advantage of this pattern and be able to find derivatives a little more easily for polynomial functions, right? But not for the definition of derivative homework. Make sure you know how to do that. All right, but before I close this video off, just in case you don't know how I did the coefficients so quickly, Pascal's triangle. It's very easy. You don't even have to memorize it because you can create it. One important thing, every row has 1 on either end. If the row only has one term in it, it's a 1. The second row is going to have 3 terms, a 1, a 2, and a 1. Right? Where did that 2 come from? 1 plus 1. I'm trying to point, and I can't. Now I can. 1 plus 1 is 2. 1 plus 1 is 2. All right, so now I'm going to do 1 plus 2. And that's going to give me 3. And 2 plus 1 is 3. But the rows have to start with 1s. Start and end with 1s. So I got to put the 1s in. Well, 1 plus 3 is 4. And 3 plus 3 is 6. And 3 plus 1 is 4. But the rows have to start and end with 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. But the rows have to start and end with 1. There's the coefficients for x squared in the second row. There's the coefficients for x cubed in the third row. Here's the coefficients for x to the fourth. Here's the coefficients for x to the fifth. It's not hard to, I don't even have to, if you don't, you can always draw it out, but after you drew it out, if you draw it out one time, you probably will have it memorized because that's how easy it is, right? And then if, I don't have to raise things to the 6th power very often, but if you looked at my, at Pascal's triangle here, 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Oh, but it's got to start and end with a 1. And there's my coefficients. So for instance, x plus h to the 6th power would be x to the 6 plus 6x, got to reduce it by 1, 6x to the 5th, h, because the terms together are always going to have an exponent of 6 as you're expanding this. And then plus 15x to the 4th, h squared, plus 20, x cubed, h cubed. Oh man, hope I can fit it across the page here. Hold on. Should have made these terms written them a little closer together. There we go. And then I left off at 15. Plus 15 x squared, h to the 4th. Oh no, okay, squeeze it in. Plus 6 x h to the 5th plus, I think I can squeeze the last term in. It's h to the 6th. Squeeze that in just barely. All right, and so you see how easy that is? So if you are going through the hard work of foiling and then multiplying values, things together to expand, please don't do that. You're working too hard. Look how easy that is. And if you have questions on that, just let me know. But I thought you deserve to know how to multiply, how to raise something to a power, a binomial to a power, very, very quickly. And that's all there is to it. All right, so bye for now. See you in the next video.